Okay, so we back at it, and like I said before we stopped earlier, I was talking about the fact that I was running the MPI module twice. I was running it with I opened a terminal where I was running it directly on that terminal, and I was also running it from the little application that we're making in Qt. So what happened is now we had 18 processes running at the same time, but remember, I only have 12, and I think you saw how all of a sudden everything was kind of slowing down. Even the way this cursor is moving on the window was kind of slowing down. It's just because I had too many um, uh, executing operations behind, and it was slowing down my machine, right? And this is just because I have so much processes that I'm calling from that program, and the number of key that I wanted to use is, I think at that point it was higher than the CPU count, which is tough. Now you see why it's important to have a good number of CPU processes that you want to use for your program, depending on how much you have available on your machine. So anyway, the code is supposed to run, and this is the file. If you go back and check the program that we're making, this is the file. And by the way, I'm not supposed to use 9 here like this, so we'll have to change it. I just realized when I was looking back at what we did before we paused, and so this is going to be changing. This is going to be changing the idea that I want to bring into this series of videos. The idea is not to do it this way. This is not dynamic. This is really static. I want to do it in such a way that I can grab this number and do something with it. So let's start by changing this line. So instead of doing it this way, what do I need? I need to cut this. Most likely I need to cut all of it. And probably have to create a Q string like this, and call it what? Command, maybe? Command Variogram MPI. I don't know. And that's the command. But instead of the 9 that you have here, maybe you want to change this into something else. And so for now, I would use the Mac alloc. Okay. And I can guarantee. Are we missing something? Oh. Yes. I need to change this into a string. That's my mistake. Now we have everything. Now how do I use this? Think system is looking for something very specific. So instead of using it, because if I use a string, it's not gonna work. Instead of using it, I need to change it to a standard string. And I still have a problem here, but that standard string, I want to grab this, right? Which means QString is just a class for handling strings when I'm in Qt. When I change it into a standard string, I'm doing something like, instead of QString, I'm using the string class, which is coming with the standard library. But again, system is not using this, right? But system will ask me to change this into it's like a pointer to this, and that pointer is grabbing the values as if you're making a table of strings. So instead of having an object, it's basically a variable from like the standard idea of a variable, right? But basically think about it as making a table where each of these characters are going to be saved in a specific case. So it's basically like you have a table 1, 2, 3, 4, 5, 6, 7, but in save, the first case is going to be M, then P, I, R, U, N, and space, and this sign, N, P, and all the other characters. So that's what we're doing here. So when you do that, now we have the idea of passing dynamically the number of CPUs. I can change this number to anything, right? And I can actually put a control here, which means if the value that I'm passing here is higher than this, display a message. But we don't want to do it now. No, we don't want to do it now. We just want to do something like pass this number. Now if I run, it's gonna work, but like I said, we need to do a few things before we run it again. So something that I want is I want to have somewhere around here, I want to have a widget where I will display the plot of my variogram. So do you want to do it this way, or how do you want to handle this? Good point, good idea. How do we want to handle this? I don't know. No, okay, let me see. Maybe it will be better if I do it this way. So I will take the widget and I will put it over here, and I can set up a min width to some values just to not everyone is a big fan of the way I'm working with this, but I understand. We all have our preferences, and this is mine. So I actually want to change the font size of this, so you can change it here, or do I want to change it, or can I just do it in the directly in the command? I don't know. I'm really thinking about it. I don't know if I want to change this here or just do it somewhere else. Because I can do it here. I can put the body size here in this HTML tag, and it will just change. Or I can just do it when I'm typing. So I don't know if I want to. Let's keep it the way it is for now, and let's focus on this. This is where I want to plot the model. So I will call this plot, not plot. All right. And what else do you need? I think I need another, maybe something similar to this, where I just put where I just push the parameters that I want to display. I don't, like I said, I don't want the user to be able to change them. So maybe a text edit is not necessarily the good option for that, but hey. And this, I can call it text edit something, maybe vario parameter text edit. Right, we're good. So this right now, I don't think I can display the plot the way it is set up right now, because there is an additional step that I need to take from here. And what else? Another thing is, looking back at the script here, I feel like I need to take these two lines somewhere else, because when I load the interface, at least I want to be able to do something like, when you display when you run your program, it will at least show you how many CPUs you have, and it will give you the option to change this number to something else, right? So something I can do is I can put something over here, like a button, some run button. How about this? I can just use a simple push button for now. Okay, and I can call it run, and I'll call it. Oh, let's keep it. No, let's put a name here just to remember. I don't know if someone is willing to change it up. Maybe it's good to have a name. Now, something that we will do is, what happens if you click on it, right? So if you click on it, I want my program to run these. Oh, sorry, to run these two lines. So now, before we run, there is something else that I want to do. Before we run, I want the user to be able to change this. Oh, I think I can do it now because that's also one of the reasons why I like this. Set CPU counts. And oh, yes. Okay. Very good. Very nice. And yeah, very nice. Very nice. Very nice. This is very good. So this is a spin box. So when you put a value here, you can grab that value. I mean, the software can grab that value and do something with it. And the way to set up now is the value that I'm entering here is an integer. It's not a double or a float. So because I know the max CPU count, I can change this max. I can change the max of this pin, right? Like you cannot exceed 9, for example. And the way you do it is within your code. So I will come up here and just put a name. Let's call it CPU. Oh, what am I doing? CPU count spin box. And what we'll do when you have this max, you can use this and change CPU max spin box, and you can set the max. Set the maximum, yeah, to this value. So if you run the script now and you want to use the spin, the max that you can do here is 9. Yeah, I can't set more than 9 CPUs, right? So now we can do something like set a default value for this. And you see where we're going with this, right? So you can, and now you think in your mind, you're thinking, well, what if you don't need your local machine to do all these things? What would be the point? Like everything that I'm doing here, keep that in mind, as in I can do all this because I know a way to grab a specific information, which is the number of CPUs that I have in my laptop. Everything that you see, the interface and all that, is because I'm doing it in a local machine, but the concept behind will not change if you decide to do this same work on a server. Of course, I don't think you will be able to do an interface. The idea when we use server is not really like having an interface, but you can have an interface to communicate between your local machine and everything that is being, uploaded in the server. And also, that's also something that I do. So I have access to CCR when I want to run something on CCR, and it's something that at some point I will have to display. I don't have to wait when my job on CCI is done, and then go there and grab the data and you know, write down some codes to display it. I have a framework already set up that I use, and it's basically like part of my let's call it a system. Part of my system is uploaded on CCR and it's waiting for a specific command. When I run that command on CCR through my gate, I can run something depending on the command that I'm running on my local machine, and it will start a specific job for me, and it will load it right on the computing node, or you know, sometimes I don't even need to load on computing node, but it's not a good idea. Sometimes you can run it directly on your, when you load into CCR, you have a terminal open. Sometimes if you have something really like not a big job, you can do it there, but it's not recommended because too many people have the, I mean, I think it's the entry point for, if I'm not wrong, all CCR users, which means if you run something there, at some point it would just stop because, you know, the way the memory is allocated, it's really depending on how many people are connected at the time you're running. But when you run something, when you load a job on a specific node, it's a different story. So anyway, you can do it so that everything that you do on CCR is there, it's running, but then your local machine is constantly checking the state of that thing. And it's just as if you were, you know, doing it yourself, right? Because when you want to check the state and you are logging into CCR, there's a specific command to do that for you. So it's basically the same process. You're not doing anything wrong. You're just using programming to do it for you, right? Instead of you doing it. And so you have this option. So keep it in mind. You don't have to, you know, you don't have to always do things in a traditional way. You can be very creative on about these things, like how you do it or how you can envision yourself doing it. Always try to be creative. I'm not saying this is the best I can do right now, but like I'm just trying to, you know, it's good if I do it and you see me doing it, and then maybe it will start something in your mind. You'll be like, oh, maybe I can do it this way, or oh, maybe I can even go like one step further and do this. That's what I'm trying to do here. So anyway, now we can set the max, but we can also set a default, I believe. And let me see if there is a set default here. Set, please. Oh no. Well, what if I said, yeah, set value, we set a default value. So set value would put a value in it, which is something you will see in the beginning. So I can set this minus, I can just set 2, right? I don't need to do something very flashy. So it will start with 2 if you set 2, and then if you increase, you can't have more than 9, which is what we want. Which means here I don't have to use this max thing anymore. I can just create the in and just use a temp, CPU count, you know what I mean? And use the spin box value. So I can just do this and you just grab the value of that spin box, which is an end, and that's all you have to do. And if I take this and I put it here, I'm all set, which means now I can run it and it will run. It will give me the output, this one, and I just have the value here. Now we have a few things to do here. The first thing is to go grab, I think I can stop for, I will explain what I will do next. I think we can stop recording for now, and then I will go grab, there is a specific package that I need for displaying the command, and maybe we can save some minutes I will go grab it and bring it to the project, and we will continue using it. So I will explain. Next, what we do, we want to display this, which means when I have this file, I want to read, and when I start reading this line, exactly this line, it means everything below is my experimental variogram. And when I read this line, it means everything below is not needed. I don't have to read the final model because this is provided in a specific binary file. That's one thing. Second thing that I can do before we stop now is I can explain how I get this, which is the part where I run the genetic algorithm that is, giving me my output. Basically, I think at this point, I will include an image to give you a general idea of what this is doing, right? And the idea is you have as an input, you have the experimental values. So you have this, and this is a plot. This is X and this is Y. So it's a curve. And what we want to do is, it's supposed to be a continuous curve, but all we have is these points, right? And we will basically do an optimization problem where you have different functions that can fit that curve, but those will use different parameters: the nugget, the seal, the range, the three parameters. So now the question is, which one is it that I will use? And so your optimization problem is defined that way. You want to find the type of model and the parameters for that specific type that will fit the experimental variogram. It's a very simple optimization problem that you can solve with genetic programming. If I know the distribution of the seal, the distribution of the nugget, the distribution of the range, and in this case, we just call it a uniform distribution because we don't want to assume anything about what could be the most expected seal or the most expected range or the most expected nugget. We don't want to run any of the, I don't want to give any sort of information about those parameters in terms of, what the distribution might be. I just think using a uniform distribution is like saying any value between the mean and the max of the seal and the mean and the max of the nugget, the mean and max of the range, has equally chance to be the best in the beginning, because I don't know. Which, again, if you think about it, you can use what I just said to take this exercise to another level, which means the first time I run my genetic algorithm, I have an idea of how good some values are and how bad some values are, and I can use that to change this distribution. I'm not doing it here. I'm just saying for you, if you want to. This is something I will probably do if I have more time, which means probably at some point when I'm done with my my current project, maybe I would take, I don't know, maybe 1 week or 2 weeks to improve this. But right now I'm fine with the way it's running when I don't change the distribution, so it should be good. But if you do it for me, I'll be very happy, and I will just I will use it, and I will cite you on my work. Yeah, but you can change this. So you can design your genetic algorithm so that this distribution is changing based on your first selection. So in the beginning, you have no idea. So you say, okay, all values from this, from that value to that value, they all have equal chance to be the best, Then you pick some of them randomly and you run your genetic algorithm to the point where you have the fitness. When you're done, for each of the selected values in this in those different intervals, you will have an evaluation, which is the fitness. Now you can use it to see what are the values that I feel like they will never make it. Oh my god, I have this name in my mind. Anyway, what are the values that I believe they will never make it, and what are the values that I think are very good? When you do it, what you do is you're changing the shape of the distribution, right? in terms of likelihood, you will have some values with, high probability of being the best, and some value with, very low probability of being the best. So now we can have something maybe Gaussian or exponential or whatever it is, right? You can do it. I know how I can do it, but I just don't have enough time to stop what I'm doing now and work on it. It might take 2 weeks or more, but because I don't know how long it might be, I don't want to stop now. And also because right now the way I'm doing it, it's fine. I can live with this actual format. So that's basically what the arithmetic algorithm is doing here. And I have my operator for computing the fitness. I have some for the crossover. The crossover is basically when the way this the concept of arithmetic algorithm is, you have a selection in the beginning. What you're trying to do is, after you evaluate, some of them will not survive, some of them will survive, and what you want to see is how can you make new offsprings, but in this case, just basically new vectors of those parameters that will most likely give you good value for the fitness evaluation. And so you do crossover operation by exchanging parameters. So maybe you take one vector with, range, seal, and fitness, range, seal, and nugget. You take another vector with range, seal, and nugget, and you decide maybe those two will only exchange the seal, or they can exchange the seal and the nugget. If they exchange everything, then it's pointless because it's just like, swapping the values around. But you really want to have a crossover, which means you keep some information and you change some other, which you can do. And in the end, you should have at least two offsprings, right? Mutation is almost the same idea, but mutation is just on one vector. So I pick one vector, and for mutation, I can actually change everyone. I can decide I will only change the type of the model and keep parameters, or I can change the parameters and keep the type of the model, or I can change the parameters and some the type of model and some parameters, or I can change everything. And mutation is where you can define some, like, okay, because I know some values are best and some values are not, I can change the distribution in the mutation. Instead of using a uniform distribution now in the mutation, I can use a normal distribution, for example. So you have some room there, but basically that's how it works. So in the end, you have, go back here. In the end, you have the best fit model. The best fit is just the one that has the best fitness evaluation. And this is another thing. This value can be very misleading because you see it's big, but you feel like, oh, this is wrong. But keep in mind that this experimental model is like you have so many points in it, right? And you would never have an experimental model where you can actually, if your theoretical model is touching all the points of your experimental model, you should question yourself, honestly. So that's why sometimes you can have a big value here. Like, let's say one of those points in my experimental model is very high, like very tall. It will bring this much weight in my fitness. So yeah, we have a file with this, so we don't need to grab it, but we will be grabbing these from the output file that we have. And remember where we do it here. Everything is saved in this file, so I can go and grab and read this file just the same way I was reading this one. So it's going to be the same thing. And that's what we will do next to display the experimental model. But now I think I can stop and I will go and grab the library that I need to use to display the experimental model, because I believe this is really the last thing we have to do here. Maybe we will have another, maybe we'll have some, maybe 2 or 3 videos now to explain the things that you can do with what we've done. Like, the step after this one, Like after you're done having a system like this, what is next? What is the what is the goal? Like, how do I use this? Right? Maybe we can have 1 or 2 videos talking about it. But for now, I think we can stop, and then I will just go grab the needed tool and we will continue.